स्केल बोल देंगे, इसको स्केल प्रैक्टिस के लिए అది ఎంత ఇగో ఇగో ప్రాక్టీస్ కేಳು ಹಾಗೆ ಇಲ್ಲ ಟರ್ನ್ ಅಂತ ಇರುತ್ತೆ ಅಂತ ಹೆಂಗಿರುತ್ತೆ ಬೇಡ ಸಾಕು ನನಗೆ ಅರ್ಜೆಂಟ್ ಆಯಿತು ಪ್ರಾಕ್ಟಿಸ್ ಕೇಳಿಲ್ಲ ಇಟ್ಟು ಪಡ್ಕೋದಂತ ಪಾಸ್ಬುಕ್ ಇತ್ತು ಬೇಡ ಎಂತ ಹೋಗಿ Okay, just a minute. Little problem because I came to native place, reached it just now only. Little setting required. If I waste the time, it will take more time. So today I will continue without a setting and not adjusting light properly also. Everything audible? Everything audible? If audible, tell me. Clearly audible? Voice clear? If voice is clear, let me know. Voice clear? I'll put the microphone on. Voice clear? But video is not clear. Board to be adjusted, but no. I reached just now because this tripod I had set right. I will restrict myself for writing within the limit. See, everything is reached late. So searching for everything. Where is the pen box now? I kept the pen box somewhere here. See, 1 minute. Okay, I got some 2 pens here. This will not do. Just a minute. When you reach late, it happens always. Last moment struggling. Right. Just a minute. Where I kept the pen? Okay. Okay, got it. Calculator also is ready. So I will restrict myself to available space. No problem. I will restrict to available space. Okay, no. Whatever is visible there, see, I will put a outline there up to where I can write, so that there is no problem. Okay, I will restrict to this line or little down, further down. Okay, I will write below this line. See, this line I restrict today, only today, because I have set the. Okay. Because now it is too late. If I try to set the tripod, because native place I reached just now. If I set the tripod now, lights on means it will take more time. Okay. I will start now. See, we are discussing very important concept. Even little light also not properly illuminated. I will put one more light tomorrow. But whatever light is visible, whatever I write is visible. One dark spot is there. I have to remove that one. See, you can see one dark spot there. Tomorrow I will remove it. Next class I will remove it. Okay. Now, See, we are discussing Euler's buckling load. Euler's buckling load, all principles today. Euler's buckling load. Euler's buckling load for a long column. For a long column. First you have to write a note. See, Euler's buckling load for a long column, you should write, is derived assuming the column to be considerably long or very, very slender. What is slender means? See, here I don't have scale here. I got a small object here. See, I got a small object here. Some book, see, if I apply a load here, or see, for example, if I take this pen and apply a load, you can see, it will get compressed. It is not a very long member. It is not a very long member. It is, or further short. See, if I take this block, imagine made up of wood or concrete. If I apply a load this way, it will get compressed. This is not a long member. This is very short member. It will never fail by buckling. There is no chance. This I told in the last class beginning only. Such short members will fail by only crushing. This all I told last time. Now, you consider, now Euler's buckling load, it is derived considering the column to be, you should write here, I will tell one by one, to be sufficiently long so that it will fail only by buckling. It will fail only by buckling. This, see, for example, see, you can take this is some small book here. See now, if I apply a load here, see what happens now, you can see, buckled. This is called buckling. There is no chance of crushing, etc. See, you take a scale, for example, thin and plastic scale. See, apply a load. You can see it correctly buckling. So, the column should be sufficiently long so that it should fail only by buckling. So, make a note. Euler's buckling load for a long column is derived. We derived for 4 standard end conditions. If you remember, both end pinned pi square EI by L square, both end fixed 4 pi square EI by L square, one fixed, one hinge 2 pi square EI by L square, one fixed, one free, pi square EI by 4L square. I told fast because already over. All those are derived. See, we put elastic curve like this. Means what? Column will fail only by buckling. First make a note. Now, therefore, Euler's formula for buckling load or expression got by Euler, you cannot use for short column. After the discussion is over, I will show you, I will give you an example where if you apply for a short column, it will give nonsense result. Utter nonsense result. Like, you go to a place, order a coffee. How much is the cost? They will tell, sir, cost is 10 lakh rupees. Or ordinary roadside hotel. You tell, how much coffee? He tells 30 rupees, 40 rupees, 50 rupees. Okay, agreed. 100 rupees. You start cursing. 100 rupees, sir. What is this? He will tell special coffee, sir. Okay, agreed. But he tell 10 lakh rupees. You can see the impression. It is nonsense. Therefore, remember, only for buckling load. Now see, we got for, first we considered both ends pinned. Then we consider both ends fixed. I am not writing everything because each and everything was told last time. So you should go through thoroughly and study. I told my class, unless you concentrate and correctly understand, my class is not meant for you. Okay, see. Then, one fix, one hinge and one fix, one free. This way, see. Now, I'll do one thing now. All of them, I'll put dotted line. Dotted line means what? Initial position. That is before you apply the load. See. Now, this column, see, will buckle like this. This column will buckle this way because slopes are 0. This column will buckle like this. This column will go here, it will buckle this way. See. Now, PB is the buckling load. I told you repeatedly, buckling load is the least load at which the column will buckle. 100 times I told. Least load at which column will buckle. So, the PB for this case, everywhere, length of the column is L. PB equal to pi square EI by L square. Buckling load. 4 pi square EI by L square. Buckling load 2 pi square EI by L square. Here pi square EI by 4L square. These are the buckling loads. Now, what we do is, you usually when you design a structure, steel or RCC, people do not want to tell one end fixed, one end hinged, rigid joint, etc. People want simple language. They want a term called effective length. Single term. Effective length. Say, my symbol is L effective. Then people decided, instead of remembering this pi square, different numbers all. First of all, see, practically perfect fixity is not possible. So some partial fixity will be there. How to remember numbers all? Number will vary. So people decided it is better to have general formula. General for any end condition. Any end condition. Buckling load PB equal to pi square EI by L effective square. Only one term. Okay, now how to get it now? See here. Pi square EI by L square. 4 pi square EI by L square. You can write pi square EI by L by 2 whole square. Here pi square EI by L by root 2 whole square. Square it. 2 will go to numerator. Pi square EI by what? 2L whole square. Therefore, if you now see pi square EI by some square. See here. Pi square here also equal to pi square EI by L square, or common term pi square EI by L effective square. So here L effective will become actual length L. So whatever is the actual length is effective length. Here L effective equal to actual length by 2. Here L effective equal to actual length by root 2. L effective equal to 2 times the actual length. Now, based on this number, IS code we see. Now, one more thing. This will become 0.5 L. This will become approximately 0.707 L. Now, in IS code, what happens is effective length is taken KL. K is the constant. See here, K equal to 1, K equal to 0.5, K equal to 0.707. K equal to 2, or suppose it is some via media case, both end fixed, theoretically 0.5, but IS code will tell you to be on safer side, consider little more length, safer side. So they will recommend, see, 0.65 L. Even though what? Expense is going to be 50 rupees, IS code will tell you, you better take 65 rupees. See, they decided 0.5, 50 rupees. So IS code told you safer side, instead of 50 rupees, take 65 rupees. 15 rupees extra. Here 0.707. They will tell 0.8. See, safer side rounding off of length is always higher side. In the design part from beginning of the course up now, I am shouting class after class what? Anything which is dangerous while designing, you should take on higher side. Anything dangerous, you take higher side. For example, what income you are getting, you should consider lesser income. If you are going to plan something tomorrow, I want to build a house, I want to buy a car, you should imagine what? I am going to get lesser money, so that you will be careful. Whereas, if you are preparing for an expense, you should take higher side. Suppose you think expense is going to be 20,000 rupees. Better be prepared for 30,000 rupees. That way. This all I told repeated in class after class. Only those who are coming to this class, you believe me. Everything I tell you have to believe me. No other alternative. In my class, if I put a dot, you have to believe the dot. Okay, start. Now, this is the formula. These all we considered last time. Okay, now onwards, remember, when we consider Euler's buckling load, you write irrespective of whatever is the end condition, we have only one formula, pi square EI by L effective square. End conditions you consider based on effect. End condition you consider it while finding effective length based on actual length. Tell me, this much concept is clear? One minute, I lost the chat here. 1 minute. Tell me, this concept is clear fast? Camera focus it. Camera focus to be done now. I'll check once again. 1 minute. Why? Whatever I am writing is visible for you, I think. See, I put a line there. Whatever I am writing is visible for you. I will restrict myself to what? Available space. Any focusing is okay now? Camera focusing okay? No. Is camera focus? Camera need to be focused little. Okay now? Okay. Okay, start. Now, remember, I told you today's class consists of concept. Concept number 1. See, now, before I go to concept, you make a note. Irrespective of whatever is end condition, from today onwards, only one formula. Buckling load for a column. Someone will ask you, end conditions. Keep quiet, don't disturb me. You tell them, keep quiet. Pi square EI by L effective square. And now tell me, what are the end conditions? See, you first tell him, pi square EI by L effective square is the formula. No, both fix both hinge. Both fix both hinge, tell now, not earlier. When I tell formula, don't disturb me that way. Now, that end condition, account in effective length. See, now, I told you already, I stands for least moment of inertia of cross section. This I repeatedly told. I stands for least moment of inertia of cross section provided L effective is constant with respect to both the principal axes. Time being, ignore it. Anything I tell time being, ignore, or believe me, I will give clarification. I am never told anything without knowing about it. Okay, start. Now, see, buckling load PB, Euler's buckling load equal to pi square EI by L effective square. This is the standard formula. Remember here, see here, or I can write one thing. E is modulus of elasticity of material. Modulus of elasticity of material. Then I is least moment of inertia of cross section, and L effective is the effective length. Effective length. Now you write to be obtained based on the actual length L and end conditions. You should write if you are interested. Okay. Now, or you can write one more thing. One who has got good structural knowledge, if he knows structures, he will not tell E and I separately. See, the term EI, he will not tell E is modulus of elasticity, I is moment of inertia. In a single term, what he will tell? EI is, what is the name? Tell me name. Tell what people will comment. He will not tell E and I separately. He will use single term EI. What EI means? He will use single term EI. What EI means? Name for EI. What that EI means? First. Instead of using E and I separately, single name EI means. What EI means? I told repeatedly. Any problem? Any camera adjustment required on me? I think camera is okay. There is some disturbance today, I think, correct? There is some disturbance today, yes or no? Lot of disturbance, I think net problem, I think most probably here. Looks like net problem. Data connection. Data connection on. Is everything visible or any problem is there? Is there any problem or visible? No, no. It is called flexural rigidity of the cross section. Now, is the writing all clear? Tell me. First of all, today remember, writing is not important. What I am telling is important today. But still, what all I tell today is important. But when I write, it should be visible there. Not with you. 1 minute. Little net problem today, I think, here. But here it is coming correctly. I don't know why. Okay, shall I continue? Shall I continue? No problem, you can manage. Shall I continue? Maybe light effect. Okay, discussions are there. Sometimes it happens. When you come in from the first time you come here, arrangements will be made. Little problem, but shall I continue? No problem. Okay. Okay, now, see. I told this one. Now see. Now what people universally done is, this formula is to be changed now. See. Now, once again write. We know that sometimes students, I will tell when I take class for academic classes, when you write, we know that you are not knowing anything. Keep quiet. You heard somewhere. But I won't tell for you. Those who are in the colleges or what, going to college, when they write, we know that, I strictly protest it. I will tell, you are not knowing anything. Without knowing, how you can write, we know that? Then they will tell, no sir, we heard it. Or tell that way. You tell, we heard it. What? We know that. Okay, no problem. We know that I equal to AR square. Yes or no? I equal to AR square. This I cannot tell here because beyond the scope of this one, this strength of materials, this is a basic one. Yes, I equal to AR square. Heard of it? I equal to AR square. Heard of it or not? At least you should tell not heard of it. You should tell we know it. Okay, yes. Now, where A is cross-sectional area and R is radius of gyration of cross-section about axis of buckling. And I told you, buckling always takes place where I is least. Therefore, R also is least value. Least radius of gyration of cross-section. Okay, now. Or if I put I equal to AR square, your R square equal to I divided by A, your R equal to root of I divided by A. So, radius of gyration is square root of ratio of moment of inertia of the cross section about the axis considered divided by cross sectional area, that will give R. If you remember, in engineering mechanics class, I gave real concept of radius of gyration, some squeezing, or if you remember, those who came to my class in engineering mechanics or moment of inertia class, I gave the real concept of R. Yes or no? The real concept of R. Others, you believe me, nothing can be done. Now I cannot leave this one and go to radius of gyration. Now you what I tell you believe. That's all. R. Now do one thing. Substitute here. If I continue this formula now, PB equal to pi square E into I is A into R square divided by L effective square, or equal to pi square E, see here, pi square E A divided by L effective by R whole square. See here, L effective square by R square whole square. Now, L effective by R, that is the ratio of effective length of column, effective length of column to the least in strength of materials least in RCC or steel applied axis, because why? Their effective length may change. So strength of materials, I told you, I cannot go that side. So least what? Radius of gyration of cross section. See, it is the ratio of two linear quantities. L effective is linear and R also is linear. Therefore, this has no unit. It is unitless, and this L effective by R is called, anybody can tell me what this L effective by R is called? What this L effective by R is called? It is called slenderness ratio. Be careful. Slenderness ratio of column. See, not column cross section. Slenderness ratio of the column. Universal symbol is lambda. People use the symbol lambda. Therefore, now you can write buckling load PB equal to, see here, pi square E into A by lambda square. Pi square EA by lambda square. See here, pi square EA by lambda square. Or if you want to understand more, if you go to steel structures, see, there is a term called pi square E by KL by R whole square. Heard of it? Pi square E by KL by R whole square is the term used in steel structures. Heard of it? In the steel compression member, IS code proposed expression pi square E by KL by R whole square. Okay. Now, here, what is one? Pi square E by KL by R whole square. This KL by R is lambda only. See, here see, your KL is called effective length, L effective. IS code take 0.8, 0.4, 0.9, etc. So, pi square E by KL by R whole square is pi square E by lambda square is equal to what? It is PB divided by area. Buckling load divided by area. Tell what it is called? Load PB divided by area. What it is called? Any load divided by area. What it is called? Name. Any load divided by area. What it is called? Force by area. Technically, what you call it? Force by area, what you call? There is a name for it. Simple language, force by area, what is the name given? This much time. Force by area, everybody knows it. People who pass engineering, they don't know anything, still they will tell. Force by area means what they will tell? What? It is called stress at buckling. That is, that is the stress. See, this is the stress at buckling load. Okay. Now, this IS code calls elastic critical stress. See there, IS code calls this as elastic critical stress. So remember, in steel structures, when you get pi square E by KL by R whole square, it is called stress at buckling load or elastic critical stress. Clear? That's all. Further, I am not telling. I am giving information for steel. Okay, leave it. Now, therefore, see here. Now, lastly, observe. You can find buckling load, user's buckling load by two different ways. Either pi square EI by L effective square or pi square EA by lambda square. Both are same. See, this is here. Moment of inertia considered, effective length considered. Here, area considered. See, what you do, this I you replace by AR square and slenderness ratio considered. This is actually more powerful. This is more powerful than this original equation. This is the original. Original is pi square EI by lambda square. But pi square ei by L effective square. But pi square Ea by lambda square is more powerful. I will tell you why. Do one thing. First come here. See. First discuss here. Pi is constant. Pi is constant. Sometimes I will ask students, you are using the term pi. Tell me what is pi. So many people will tell, sir, 3.14. I will tell what is pi. Sir, 22/7. Don't talk nonsense. I will tell what is the real meaning of pi. Unfortunately, so many people are not knowing what is pi means. I know it. I have seen my teaching career for spanning more than around 40 years now. I know 99% people are not knowing what is the meaning of pi. They will tell 22/7, 3.14. Real meaning of pi, I am not telling everybody is not knowing. Majority are not knowing. Okay, leave it. I won't discuss mathematics here. In the YouTube class, one fine day, I will upload a class about the importance of this pi. What is the real meaning of pi? It has got sense. It is not nonsense. Okay, pi over. It is a constant. E is modulus of elasticity of material. So for a material, E also is constant. Therefore, your buckling load PB is proportional to I and inversely proportional to what? L effective square. Buckling load is directly proportional to I and inversely proportional to L effective square. Now, see, tell me. Class after class earlier I was shouting. Moment of inertia, I will tell you. Cross-sectional area A, then moment of inertia I, suction modulus Z, it will come in bending test, and radius of gyration R. These are all, remember, how much is the area of cross section? Then, how much is the moment of inertia? What is the section modulus? It comes for bending. What is radius of gyration? These are all, tell me, strength supporting factor or strength destructive factor. Strength supporting factor means you are happy if they increase. Strength destructive factor means you are unhappy. Like income is strength supporting factor. More and more income you get, you are happy. Expenses, strength destructive factor. More and more expense comes, you are not happy. See, profit, you are happy. Tax, you are unhappy. Why? Something which is not so helpful for you, you are not unhappy. I told class after class, cross-sectional area A, moment of inertia I, suction modulus Z, and radius of gyration are all strength supporting factor or strength destructive factor. They are all, oh thank you, sir, ratio of circumference to diameter of circle. How you got it? From where you got it? Somebody answered there. What is the meaning of pi? From where you got it? Okay, thank you. Somebody answered there. Ratio of circumference to diameter of a circle. Tell me where you got it from. May I know where you got that answer from? No. Someone commented there. Thank you. Good answer. But may I know where you got that answer? No idea? Where you got it? Why? Don't want to tell where you got it? From math. Really good. Okay. I see, if you tell good things, I appreciate. When I take the class, I grind the students. I will show them where they stand. But when such good answer comes, I appreciate. I will not tell, I can find fault with anything. Whatever you tell, I can find fault. But I am not that type. You tell something correctly, I will appreciate. Okay, good. Now, these are all strength supporting factors. Therefore, tell me. Therefore, see here. Pi square EI by L square. Therefore, higher and higher value of I is good or bad. Higher and higher value of moment of inertia is good or bad? Fast. Higher value of moment of inertia is good or bad? They are good. That means good. Why? Or good. Or see here. Pi square EI by L effective square. As I increases, buckling load also will increase. Good. Buckling load increase means column will buckle at a higher load. See, I need to buckle this column. See here. To buckle this column, I need a load of say 1 kg. See now, buckled. See, buckled. To buckle some other column, I need higher force. See, whereas to buckle this column, I may need 100 kg. Oh, very strong. So buckling load more means column becomes stronger. And as I decreases, buckling load also will decrease. That is, if the buckling load decreases, it means what? Column will buckle at a lesser load. Good or bad? Bad. So, directly proportional I. Then L effective. See, L effective comes in denominator. Tell me. Column becomes more and more long. Good or bad? A column becomes more and more long. Good or bad? Column becomes more and more long. Good. Yaru good adu? Hale answer. Okay. Bad. If the column is more and more long, bad. See here. I will take a column here. See. Some column I will take. See. I will apply a load here for a small length. See here. It can't buckle. I will take little more length. See. Oh, gone. I will take further more length. See. So, as the length becomes more and more, column becomes weaker. It will buckle very easily. Therefore, remember that denominator L effective is bad. It is bad. What is bad means? We do not want it. It is self-strength destructive factor. Therefore, as L effective increases, column becomes weaker. Why? It will buckle at a lesser load. Whereas as L effective increases, it will buckle if it increases. As L effective increases, as L effective decreases. When the denominator decreases, value will come more, it will buckle at a higher load. Therefore, remember, the column strength is proportional to I, inversely proportional to L effective. Over. Now come here. This is also same thing. See here. Here, area is constant for a cross section. Or, as area is more and more, column becomes stronger. And lambda equal to, see, L effective by R. This is the real concept of buckling. See here, you talk only about L effective. What about cross-sectional dimensions? Cross-sectional dimensions, your study in I. To understand the cross-sectional dimensions weakness, you have to go through I. To know the weakness of length, you have to go to L effective. But here, if lambda, we are considering both what? Length effect and cross-sectional effect. L effective by R. Or, I will give a simple example. See, lambda is slenderness ratio. How slender column is? Tell me. Do you want a column? You are going to construct a house. Do you want a slender column or not? Do you want a slender column? Suppose you are going to your own construction. Do you want a slender column? Tell me. Do you want a slender column? You are going to construct a house for yourself. Do you want a slender column? Fast. Slender column. Do you want it? It is bad. Nobody wants a slender column. See, by name only, slender, weak. Or, I will make this L effective by R more clear now. See, I will make it L effective by R more clear. slenderness ratio, that is lambda equal to L effective by R minimum. I will tell R minimum. Least radius of variation of cross section in strength of material. See now. Correctly observe. L effective increases and R minimum decreases. Correctly what I tell, understand now. Effective length becomes more and more. Column becomes more and more length and it becomes thinner and thinner. Remember, this R is directly proportional to the thinner side. This I will prove you little later. Right now, believe me. So, as the cross section becomes thinner and thinner, column is not, see, you can make out. I told you, if the column becomes thinner and thinner, it is weaker. So, your R will decrease. So, L effective increases, R decreases. Both of them are good or bad. High length and thin section. Both are good or bad. Good or bad. High length and thin section. Both of them are good or bad. Tell me. High length and thin section. Both good or bad. You have to answer. Good or bad? They are bad. Both are bad. Therefore, as L effective increases or decreases, your lambda will increase. Lambda will increase and will tend to become what? Become a slender column. Slender column. Actually, very, very bad. Very, very bad. Slender column will buckle very easily. See here, length increases, section thinner and thinner. See, or see, imagine a column, huge length and thin cross section, very weak. Now, on the positive side, black color. See, lambda equal to what? L effective by R minimum. Okay. Now, as L effective decreases, column becomes smaller and smaller in length. See, this way. And R minimum increases. Means column becomes bulge. See, bulging. Length is reducing, cross section wise bulging. Good or bad? Length reducing, cross section bulging. Good or bad? Length reducing, cross section bulging. Good. Why good? This column cannot buckle, or here your lambda will decrease. Good. Lambda will decrease means it will tend to become a short column. That is good. Therefore, lastly I will tell, closing part, remember once for all, higher I, good. Higher area, good. And then higher R, good. Then higher length, higher L effective, bad. Then lesser I, bad. Why? Moment of inertia, area and R, they are strength supporting factor. And lesser I bad. And lesser area also bad. Then lesser R also is bad. But remember, lesser L effective is good. This all I explained. Now, instead of that way, I can tell single language now. I can tell in single statement, one line, slenderness ratio, lambda equal to L effective by R minimum. Okay, tell the answer. higher lambda, good or bad, single term. Now area not required, moment of inertia not required, L effective not required. One name, L effective, length by thickness, thinner side, higher lambda, good or bad, higher lambda, good or bad, higher lambda bad. Why bad? Column will become chance of buckling chance. Tell me, lesser lambda, it is good, because here higher lambda means column will tend to become long column. Lesser lambda means good, because why? No buckling chance is avoided, column tend to become short. Okay, this concept, tell me, fully clear? I will not repeat class after class now. Only once I will tell, I will not tell again and again. Lambda is bad. Lambda bad. But bad thing, L effective supports lambda. R minimum but resist the lambda. Higher L effective and thinner section, bad. Lesser L effective, then lambda is higher. Lesser L effective and bulged cross section, good, short column. If clear, I need not repeat. You can go through the statement again and again till you get the control. Okay, now I will do a numerical example now. See, I will do a numerical example. First, see, I will take a simple example of I will do one thing now. Simple example, see. A column is of cross section, simple example, 200 millimeter, I will take a thin member, see, 60 millimeter by other side is 200 millimeter. 60 millimeter by 200 millimeter. Rectangle section, quite thin. Okay, now, length of column, actual length means actual length of column is quite bigger actually, 4 meter. Why 4 meter? I want column to fail by buckling. Okay, 4 meter. Then one end of column is fixed while other end is free. That is like a electric pole or a post where fixed at the ground, free at the top. Imagine somebody is applying a load there. Okay, now E equal to 200 GPa over, and E is 200 GPa. That's all I am giving. I am not telling any other property now. Okay, now applying Euler's formula, find the buckling load. 1 minute, make a note here. Sometimes Euler's formula is not applicable. If you apply Euler's formula, it will give you nonsense results. But right here, that all will come later, in a little later. Right now, you should not go beyond a limit. Today, you tell my name, he told, you tell KSN told, apply Euler's formula, get the buckling load. That's all. Somebody can comment, sir, you are not given the crushing strength, so I cannot check whether applicable. I will tell, keep quiet, time being. Time being, what I tell, do that much. A time will come later when I will talk with you, then answer the question. Right now, don't go beyond a limit. Limit yours, not applicable to the regular viewer. Sorry, those who are in the BSK batch, those who are coming regularly, this is not applicable for you. I told you, this is for general public in YouTube, where people will tell this way, that way. For them I will tell. What I tell, do it. That's all. I told you, what I tell, do that much. Okay, start. Now, see correctly. I'll write one by one. See, when I solve, I will take unit newtons and millimeter. I will stick to newtons and millimeter. Okay, start one by one. First I will do one thing. E value. Why waste time? 200 GPa are equal to 200 10 to the power 3 MPa. You know that the MPa means what? MPa means Newton per mm square. If someone will ask, sir, why? Why means study if you want. You can't expect me to tell each and everything here. Okay, then E over. Then the column, they told one end fixed, one end free. Length of column is 4 meter. The 4 meter is L. L is the L. Okay, one. Now, actual length L equal to 4 meter. Therefore, we want effective length. We do not want the actual length. See, if you use the actual length, you can solve. Then what you have to do? You have to use the Euler's buckling load for a column with one fixed, one free. That is pi square EI by 4L square. No, you use one formula. Effective length. L effective equal to how much? Answer is 2 times actual length equal to, see, actual length for one end fixed, other end free. This I told you repeatedly earlier, or equal to 2 times 4 equal to 8 meter. Or I told I want in millimeter 8000 millimeter. Okay. Now I will remove all this now. See, therefore I told everything in newtons and millimeter. I got E equal to 200 10 to the power 3 Newton per mm square, comma, I got L effective equal to 8000 millimeter. There is a reason for this question. It is not for time pass. Remember, this question is not for time pass. Okay, then that's all. Now, this all I can remove. And also, the cross section of the column is rectangular section. Any side you can write horizontal. One side is how much? One side I told 200. I forgot. All dimensions are in millimeter. One side is 200. Anybody can tell me? I forgot now. What is the other side I told? You know, I forget things very fast. What is the other side I told? One side I told 200. Other side I told, forgot. 60 millimeter. Thank you. Other side is 60. This is the cross section. Now do one thing. You draw the axis. See correctly. Red color I will draw. One of them is this axis. Other is this axis. This is XX axis. I will call YY. Your choice. You can turn the column also. Okay, now. I told you repeatedly what? I stands for, I told 1000 times what? Least moment of inertia of cross section I equal to, tell me, if I want equal to what? Equal to I about XX or I about YY, the two principal axes, among the two, whichever is least. Anybody can tell me what is I about XX axis? See, now you should know basic. If you want I about XX axis for rectangle, it is BD cube by 12, which is the side parallel to axis. So for XX axis, 200 is the side. 200 into 60 cube divided by 12. Tell the answer. You tell me in 10 to the power 6 millimeter power 4. Tell the answer. Tell the least IUXX 10 to the power 6 millimeter power 4. Answer. 10 to the power is not required. 200 into 60 cube by 12. You 10 to the power 6, leave it. Tell the number. I want the answer in terms of 10 to the power 6. Bega, fast. I want in terms of 10 to the power 6. This much time to decide 10 to the power 6 number. 3.6. Okay. 3.6. and see, and I about y axis here. I about y axis is side parallel to y is 60. First of all, I need not tell. When you come to column chapter, you are supposed to know about moment of inertia. Okay, it is 60 into 200 cube divided by 12. Answer. 60 into 200 cube divided by 12. Answer. I once again want 10 to the power 6 millimeter power 4. Answer. It's 40, yeah? 40, okay. 40, 10 to the power 6. Okay. Now tell the answer. Therefore, what is the least? See, I told you want least moment of inertia of cross section, that is I minimum, is what? 3.6 10 to the power 6 millimeter power 4. Actually, tomorrow class or next class, when I get good quality of the board and also write all, I will bring a member here, the demo experimental member, and show you how it will buckle. Okay, now start. Now see, time being, if you use original formula, original or basic formula, basic what? Euler's formula, then buckling load, or I'll write here, Euler's buckling load, PB equal to pi square EI divided by L effective square, equal to pi square E is 200 10 to the power 3, 200 10 to the power 3 into I means least I is, see, I means what? Least value, 3.6 10 to the power 6 divided by L effective square. How much it is? Where is it? L effective, 8,000 square. 8,000 square. Remember, all substitutions in newtons and millimeter. When all substitutions are newtons and millimeter, load will come in Newton, or see here, Newton per mm square into mm power 4 becomes Newton what? Mm square. Newton mm square by mm square will cancel, answer will come in Newton. High school or primary school mathematics, answer. First of all, nowadays, somebody LKG, UKG may tell, sir, I also know this one. Okay. 10 to the power, I want the answer in 10 to the power 3, so that Newton I can convert to kilonewton. Answer. This is the buckling load for the column. 10 to the power 3 alkodi. Tirupatiya. Tell the 10 to the power 3 alkodi. 111.033, I don't know. No, you don't get 10 to the power. I wrote the answer in terms of 10 to the power 3. 111.03. See, 111.03. For fun, some I tell Tirupati. When 3 comes here, for fun I will tell Tirupati point something. Okay. This is Euler's buckling load in Newton, or you can tell 111.03 kilonewton. So this column will buckle about which axis? XX or YY. See here, your least I came for XX or YY. This column, according to Euler, will buckle at a load of 111.03 kilonewton, and that buckling will be about XX or YY. Tell me. That buckling will be about XX or YY. That buckling is about XX or YY. It was better to decide. That buckling is about XX or YY. About XX. Or now I will give a common sense. I will give a common sense answer, so that anybody on the road will understand, not you. Somebody walking in the road will tell. If he see this one, he will tell, correct, I know it. You don't have to tell. See, just for understanding purpose. See here. See, this is the column. See here. This is 200. This is 60. This is 200. Correct now? See, this is 60. This is 200. When you apply the load, tell me. See, this is 200. This is 60. When I apply the load, tell me, will it buckle like first way or second way? Nodi, this is the column. See, this is 200. This is 60. You take a scale or plastic scale, apply a load this way. Will it buckle the first way or second way? Heady. First way or second way? XX way better. Will it buckle the first way or second way? It will buckle the first way. Now, if it buckled this way, this is the axis for buckling, remember. Or I will tell you only once, because this I told repeatedly in earlier some strength of materials. Every day I cannot tell. Remember, I will tell you important concept to remember. For general public, those who are in the BSK, this is told endless number of times. See, for general public, those who got difficulty, I will clarify now regarding axis. Okay, now, according to physics, what is the thing? See, first of all, axis. What is axis? See, I will tell you physics. First of all, I need not tell this one, but I am telling so that general public in future will have benefit. See, in physics, what they tell? A body is said to be rotating about an axis if each and every point in the body remains at constant distance from that axis. See now, see, I will tell you, a body is rotating like this. This is the rotation. If this is the rotation, this is the axis. See now, this is the axis. Why? See, throughout rotation from this hand, it is constant distance. Or if a body is rotating like this, see here, if the body is rotating like this, then this is the axis. See here, from the axis throughout it should remain at a constant distance. Whereas if a body is rotating like this, see, this way, then this is the axis. Or what you have to do is, in future, from today onwards, if by chance someone will ask you, show me the axis, what you have to do? You tell him, show the bending or rotation. See, rotation means free. See now, you can rotate like this. Bending is no problem. If bending this way, you bend and then rotate. See, slightly bend and rotate. See, or bending this way. See here, slightly bend and rotate. Or see, twist, slightly twist and rotate. In future, wherever you go, you should remember what I told now. What you do is some easy method. You put the axis so that the rotating one is at constant distance from the axis. Or easy method. See, sometimes students, when I ask, they will tell very easily. See, if it is this way, see now, this is the axis. See, see now. This is the axis. Fully clear? Fully clear or not? How to decide the axis? Fully clear or not? I will tell one more point. Fully clear how you decide the axis in future. See, if somebody is rotating like this, you tell him this. See, somebody rotates this way, you tell him this. Somebody rotates like this, you puncture it. This is the axis. Okay. Now one more thing. This is general public and extra for structural engineering. extra for structural engineering. See, I will not tell again and again. In structural engineering, a term called bending moment or torsional moment will come. Torsional moment will come. This is always for what? Tell me. Bending moment or torsional moment, axial force, shear force not required. Bending moment and torsional moment, they are suction forces. They should be resisted by what? I will not tell once again. Tomorrow's class, if somebody comes, he puts a comment, sir, axis not clear. Leave my class, I will tell him. Don't come to my class. If I told that much, if you don't understand, you are not fit to be my student, I will tell. Listen everything I tell. Bending moment and torsional moment, they are what? Correct. Resisted by cross section. I told 1,000 times. Resisted by cross section. Sometimes I write full board. Resisted by cross section. Okay. Therefore, when you decide the axis for bending, remember, buckling is also bending. You make a note. Buckling is also bending. Bending moment or buckling or torsion, your axis should lie in what? When you decide axis for bending moment or torsional moment or buckling is also bending. Your axis should lie in what? Your axis should lie in. Answer. Your axis should lie in. Should lie in. Very important. The axis should always lie in cross section. So axis should always lie in cross section. Now see. Now correctly see. I will tell only once. Only once I will tell. See, repeatedly I cannot tell. There is a limit for explaining. See here. Buckling like this. See. See. This way buckling. Tell me. This way buckling. You see the cross section. Cross section. Tell me. This way buckling. See. This buckling this way. See. Is the axis buckling this way? First one or second one? Is the axis first one or second one? Axis first one or second one? Buckling this way. See, cross section here. You can take either this axis or this axis. First one. Okay. Now, buckling this way. See here. Is the axis first way or second way? First way or second way? Second way. That's all. So, in future, remember, buckling this way. See my hand. Buckling this way. This is the axis. Buckling this way. This is the axis. I will not repeat once again. Agreed? Up to end of this teaching of columns, I will not repeat once again. Agreed? I will not tell once again. I will tell the people who tell not clear, leave my class. I will tell, leave my class. Don't come to my class. Sometime you should be harsh for such people. Okay, thank you. Now, remember now, permanently. Okay, now do one thing. By chance, instead of considering least I, that is for this example IXX equal to how much? 3.6 10 to the power 6 millimeter power 4. I'll write here now. Suppose by mistake, we consider I about yy. That is how much? 40 10 to the, don't by heart. Today it is yy, 10 to the power 6 millimeter power 4. Then it is actually utter nonsense. It is nonsense statement. Then your Euler's buckling load will come pi square into E 200 10 to the power 3 into I 40 10 to the power 6 divided by 8000 square. Tell the answer in 10 to the power 3 Newton. That is, I will tell in kilonewton. Answer. Tell the answer in 10 to the power 3 Newton. High value you are getting. Tell the answer in 10 to the power 3 Newton. I will convert to kilonewton. Answer. I will convert to kilonewton. You leave 10 to the power 3. Itot beka. This much time to get it. 1233.7. 1233.7 or 1233.7 kilonewton. Or when you took the least I, buckling load is 111.03. Tell me, real buckling load is 111.03 or 1233.7. What is the real buckling load? 111.03 or 1233.7. Real buckling load. How much? What is real buckling load? Real buckling load 111. Now, if someone tells 1233.7, then I should tell this way. Once upon a time, see a story. You tell somebody going in the road will laugh at you. People without structural knowledge, he will laugh at you. You tell them, once upon a time there was a column. With that column is found to buckle. See, that column, when you apply a load of 111.03 kilonewton, the column buckled like this. Okay, then as you increase the load, slowly column stood up once again. Then when the load reaches 1233.7 kilonewton, what happened? The column once again buckled. Possibility is there. The column once again buckled. Possible. At 111.3, the column buckled and failed. Then it will stand up once again. Never. Or it is like telling, when the electric current is 111 volts, someone got hit by it and collapsed. And what happened? Some problem with him. He has got medical problem. Doctor told him, you should not take electric shock. 100 degree, 100 what? Above 100 volts, if you take electric shock, your life is in danger. So there is a person who, when the electric current reaches 111 volts, he will collapse and gone. Then you tell him. Then once again he will stand up, he will come back to life, and when the power electric current reaches what? Voltage 1233.7 volts, again he collapsed. Nonsense answer. 111 he collapsed and gone. His relatives came, function started there. Where he can reach 1233.7. That's why for buckling, always consider which moment of inertia. For buckling, always consider which moment of inertia. First, when you want buckling load, always consider which moment of inertia. Always consider which moment of inertia. Least moment of inertia. Thank you. Now I will not tell once again. Okay, now this question just now we solved by using Euler's basic expression. Now do one thing. See, now we will solve by what? Popular and practically useful version version of Euler's buckling load. Euler's formula. That is what? I write here now. That is Euler's, I write here. Euler's buckling load. Euler's buckling load. See, remember, that is PB. Actually, remember, pi square EI by L effective square is the most popular formula. It is very, not popular. It's the basic formula. Derivation is done that way. But the real conceptual formula where you will understand the behavior is PB equal to pi square EA by lambda square. Okay, start. Pi square EA by lambda square. Okay, I'll find this way and go for next one. Start one by one. Pi is already over. E is already over. Tell me, what is cross-sectional area A? Area A equal to 200 by 60. See now. It is 200 by 60. Direct answer. Tell the answer. Area in millimeter square. Answer. 200 by 60 is the cross-sectional area in millimeter square. How much? 12,000. Thank you. It is 12,000 millimeter square. Now you require lambda. Lambda is slenderness ratio. That is L effective by R minimum. L effective by R minimum is lambda. Start. We already know L effective equal to 8,000 millimeter. Already known, basic. Why? Length is 4 meter. One end fixed, one end free. Already I told you. Over. Down. R minimum equal to square root of I minimum by area. Start. I minimum, once again I will solve. I minimum equal to I about XX or I about YY among the two, whichever is least. Ready? Among the two, whichever is least. Or 1 minute. Whichever is least. The color is gone here. I don't know where the red color gone. The red color pen is here. Okay. What happened? One color, extra cap is there. The dangerous one. If extra cap is there, that is there is one pen which has lost the cap. I will not be able to write once again later. Okay. Okay, here, one more extra cap. Okay. Ayyo, right time not getting color. It's the usual problem with me. When I want the red color, I won't get it. Yep. No, really killing me. Oh, it's here. It's as well. Okay, see. Now, see correctly, this is XX, this is YY. Now, directly write here. I about XX, see. I about XX or I about YY. Now, I about XX is 200, which is the parallel side, that one. 200 into 60 cube divided by 12. I about YY is 60 into 200 cube by 12. You can find both of them. What is the answer? Therefore, you can tell I minimum. Tell the answer. Directly I minimum. Answer. In 10 to the power 6. Lesser value. Tell the I minimum. You already know it. How much I minimum? How much? No. I minimum how much? I minimum. What is I minimum? One of them is 200 into 60 cube by 12. Other is 60 into 200 cube by 12. I minimum. How much? No. Answer is correct. Answer should be correct. Guaranteed. It's my class. My class, no chance of wrong answer. What is I minimum? 3.6, 10 to the power 6. Actually, you can do one thing. You are wasting your time. See here, you are cubing 60, you are cubing 200. Therefore, you can tell undoubtedly, nodi, 200 into 60 cube, 60 into 200 cube. So, you need not waste time when you want I minimum. Directly you write longer side into shorter side cube by 12. Clear? Directly without any argument, longer side into shorter side cube by 12. Clear or not? You need not calculate both because quite obvious. In one of them 60 cube, other is 200 cube. Least value is longer side into shorter side cube by 12. Clear or not? Is it clear or not? You don't have to waste time that one. Clear? Fast. You are not answering. Is the concept clear? Directly longer side into shorter side cube by 12. Don't waste time. Shorter into longer cube. Why? It will give higher answer. You are not answering. Clear? Okay, I won't ask you because you are not answering. Okay. Therefore, direct answer. Okay. Now therefore, R minimum equal to square root of 3.6 10 to the power 6 divided by area is 12,000. Answer. What is R minimum? R minimum. See, I is in millimeter power 4. Area is in millimeter square. Millimeter power 4 by millimeter square is millimeter square. Root mm square is mm. Answer. 17.32. Can you give more number? 17.32. Can you give it more number? Can you give it more number? 17.3205. Correct? 17.3205. Your lambda equal to 8,000 by 17.3205. Remember, this is millimeter, this is also millimeter. Lambda has no unit. What is lambda? Lambda has no unit. What is the answer? 8,000 by 17.3205. Answer. At least third decimal. At least third decimal. 8,000 by 17.3205. At least third decimal. Answer fast. 461.880. 461.8802. Now it will substitute in the formula. Buckling load equal to I square into 200 10 to the power 3 into area is 12,000 divided by lambda square 461.8802 whole square. Answer will come in Newton. Tell me 10 to the power 3 Newton or I will convert to kilonewton. Answer. It has to come what answer we got earlier. How much answer? How much answer? Why not clear? Okay, closing part. Okay. Now voice okay? Now voice okay? Now voice is okay. There is okay. Closing part somehow manage. ಮಜ್ಜಿಗೆ ಊಟಕ್ಕೆ ತೊಂದರೆ ಅಷ್ಟೇ. ಮಜ್ಜಿಗೆ ಸರಿ ಇಲ್ಲ. ಆನ್ಸರ್. ಎಲ್ಲ ಎವ್ರಿಥಿಂಗ್ ಫುಡ್ ಇಸ್ ಗುಡ್. ಮಜ್ಜಿಗೆ ಇಸ್ ನಾಟ್ ಗುಡ್. ಓಕೆ. ಆನ್ಸರ್. ಓಕೆ. ಆನ್ಸರ್. ನೋ ಎಕೋ. Answer 111.03 111.03 or 111.03. Now I will give a secret thing for you. See, for rectangular section, I will take next class. For rectangular section, in future, you need not bother about I and area. Very useful for competitive examination. Rectangular section only. For rectangular section, your R minimum is always equal to lesser side find area, known you are finding I by A. It is a rectangular section directly equal to lesser side by root 12. If it is circular section, it is 1/4 of diameter. This will tell you next time. Answer 60 divided by root 12. What answer? 60 divided by root 12. What answer? 60 divided by root 12. Is it once again 17.3205? Tell me. 60 divided by root 12. Is it 17.3205? Okay. You can yes is sufficient for me. If answer is yes, I will close the class. Already 9 o'clock. Is it 60 divided by root 12 is 17.3205? Correct or not? Fast. You tell correct, I will stop. Correct. For that matter, I will tell you one thing. When I wrote this number here, I took my calculator. I will tell you, I never considered I value. I never considered area value. I took my calculator and calculated 60 divided by root 12. Wrote the answer. Why? It is a concept. Okay. Next class, we will cover more and more concept and application. Okay. Thank you. All the time over. I will close because I hope next time not much, only 2 days, because then I will back in Bangalore. 2 days you have to manage with this net problem if it is there. Only 2 days. Tuesday, Wednesday, that's all. Then Thursday I will be driving back. So next day onwards I will be back in Bangalore. Nothing to worry. Okay. Thank you.